Hey guys, welcome back to another video. Today we will be talking about Niels Bohr and his atomic structure. Before we talk about that, we need to talk about Ernest Rutherford's atomic structure and what went wrong with it. Ernest Rutherford's atomic structure was actually quite applaudable when it came, but it was wrong theoretically. This is because of the following reason. We know that electrons in nature move around in a circular motion around the nucleus, right? So when these electrons move around the nucleus, Rutherford stated that they gain acceleration and this caused them to release energy. But if they released energy, they would, and he also stated that eventually they would fall into the nucleus. And we know that this isn't true because if the electrons fall into the nucleus, the atom will be unstable. So this doesn't happen in nature because we know that all atoms in nature are stable, and so we know that this theory was wrong. And Niels Bohr came up with two rules that slightly, and this theory which needed modification, Niels Bohr actually added specific rules to it which made it more clear. The first rule is only certain special orbits called discrete orbits or shells of electrons are allowed inside the atom. The second rule is that while revolving around the nucleus, electrons do not release energy. These rules prove that atoms are stable in nature. Bohr developed the Bohr model of atom, in which he proposed that the energy levels of electrons are discrete and that the electrons revolve in stable orbits around the atomic nucleus but can jump from one energy level or orbit to another. In about the jumping of electrons, we'll talk about it in the later part of the video. Although the Bohr model has been supplanted by other models, its underlying principles are still true and valid. And now the atom which contains the orbits, they need to be named specifically, right? So the names of the atoms, you can name them in two different ways. One of them is alphabetically and the second one is numerically. So the alphabetically, we start from the near closest orbit to the nucleus. The first orbit is called the K shell, L shell. The next one is called the L shell, and after that it's the M shell and the N shell, and so on. If there's more shells, it depends on the number of shells actually. So it starts from K, L, M, N, O, P, Q, R, and etc. And numerically, from the beginning of the nucleus, we can name the atoms like N equals 1. The first circle is called N equals 1. The second orbit is known as N equals 2, and then the third one is known as n equals 3, n equals 4, n equals 5, etc., etc. But the thing to be noticed is that the n is should be in small letters. Now let's talk about the movement of electrons in the atom. We know that electrons are constantly orbiting the nucleus, right? But sometimes there's photons that hit these electrons, and photons contain some voltage of energy which the electrons need. And when this energy is hit the when this energy hits the electron gains energy and moves up or up an orbit or two orbits or three orbits depending on the number of amount of energy given by the photon. And according to the Bohr's rules, we know that the electrons do not release energy for no reason at all. They need to have a specific reason why they release energy, and the only way they can release energy is when they absorb the energy from the photon, right? And after that, the energy when they go up and they go up an orbit, right? And when they want to release the energy, they can release the energy in form of another photon and they go down another energy another orbit, and the photon that is released released by the electron is what we see as light. And that's all I have for today. Hope you enjoyed this episode of Talk About Scientists, and see you in the next video. Thank you.